What we are watching is H3 rocket number 7, carrying the new HTV-X space station resupply vehicle. The rocket will launch from Tanegashima Space Center, and the launch time is 9 o'clock 15 seconds. Good morning, everyone. Welcome to JAXA launch live stream. This time, MC is freelance announcer Isogai Hatsuna, and thank you for joining us early in the morning. And hi, I am Chikara Ishikawa from the JAXA HC project team, and I'm in charge of providing technical explanation about the HC rockets. Thank you very much for your cooperation. And good morning, I am Kenta Nagahama from the JAXA Automated Docking Technology Demonstration Project team. I'll be providing technical explanation for the new space station resupply vehicle, HTV-X. Thank you for your cooperation. And today's broadcast is live from the special venue at the Tsukuba Space Center. Mr. Ishikawa, Mr. Nagahama, the day has finally come. Yes, the day has finally arrived. And actually, because of the weather, we had to extend several days. And actually, the H3 rocket's new booster is in its strongest configuration with the 4 engines, and the launch of HTV-X1 are here. And actually, this time we have worked with so many people, but actually now we have a kind of moment that we can launch it. And also you are watching, this live are our members, and with so many members, we are so much happy to be supported. And Mr. Nagahama, what do you think? And actually, I served as flight director for Kono number 7 through 9, and subsequently spent many years advancing the development of HTV-X. Actually, I was in charge of the final operation, the shift for the Kono 9, and my final work then were the Kono end with Flight 9, but we will return with a new space HTV-X. And actually, in the final message, it was broadcast worldwide. And yeah, that's right. And 5 years have passed since then, and we have finally reached this day. As someone who has been involved in the development of HTV-X for a long time, I'm truly filled with deep emotion. Well, actually, I felt so much excited to end today. Please note that simultaneous interpretation into English is also available for today's live stream. You can access it via the link in the YouTube description. Now, there are 50 minutes left until the launch of the H3 rocket number 7, and originally scheduled for October 21st, but the launch was postponed 5 days due to poor weather conditions leading to today's launch. And actually, at the time, anyway, we made a big telltale balls, and not only here, but actually at NASA, there are so many telltale balls made by so many people, and we have been waiting for that. And Mr. Yui made also very cute telltale balls. And finally, we had today, Mr. Ishikawa. It seems the weather is quite important. Oh yes, actually this time the weather was so strong, therefore it was very bothering. And every day we checked the wind, and finally, anyway, we could have this day. And actually, of course, the rocket must be ready, but weather conditions, rain or wind or thunder, everything must be kind of set for the launching. And actually, now today's weather. Oh, what's a day? The sky is clear. That is fantastic, and it's a beautiful blue sky. And actually, this is a perfect launching day. Yes, I think so. I really, envy the people who can see at the site. Actually, until yesterday, I was a bit worried, but anyway, it's perfect today, and there is no sky anymore. Actually, the power of the telltale balls works so much. And actually, there's a lot of connection with various places. First of all, let's pay attention to the LCC in Tanegashima. Okay, this is Launch Control Center, and actually, the LCC function checks on the rocket for the upcoming launch have been completed, and the final preparation for the countdown are now underway. And actually, the person, this is the person. Now he is talking, is a kind of responsible person. You can see very well. Thank you very much. And also, we are connecting with RCC. And actually, the front section primarily houses the team responsible for tracking and controlling the rocket after launch. There are sections in where the managers, you can see the monitor, and also just a 5-minute walk from this race stage. Let's take a look inside the HTV-X mission control room within the Tsukuba Space Center. Yes, actually, here at the HTV-X mission control room at the Tsukuba Space Center, we are conducting final launch preparation in coordination with the members of the Tanegashima Space Center. And following the launch and the separation of the H3 rocket, this control room will conduct operations to guide and control HTV-X to its destination in the International Space Station while maintaining communication with the spacecraft. And I will bring you updates from the Space Center. And today's schedule is as shown like here. And also the launching is 9 o'clock 15 seconds. And today we have a special message from the space. What message can we listen? Let's wait for it. And well, actually, the launch is coming very soon, and now I'm feeling kind of nervous. As for the rocket, it moved last evening, and after that, a lot of inspection was done, and so many people never slept through night, and now rocket condition is good. Thank you very much. And anyway, theme of today's broadcasting is, let's see the historical point. And please tell us that today's point. Yes, actually, there are 4 solid fuel booster, and actually this time for the first time 4 boosters are applied, and so far there are just 2. And also on the top of this one, actually this is the wide fairing is provided. And next, Mr. Nagahama, please tell us the point of the HTV-X, and actually that is for the first time the new supply vehicle is launched, and actually making the best use of the technology nurtured in the Konotori. More cargo can be supplied to the IS, and some other point. Anyway, there are other point I'd like you to pay attention to. After separating from the H3 rocket, the flight operation towards the IS begin. As it approaches the ISS crew will be able to see the HTV-X in flight. Furthermore, the HTV-X features significant changes in appearance compared to the Konotori, therefore such as the adoption of deployable solar panels. I'm really looking forward to seeing its appearance in flight as it approaches the ISS. Anyway, this is truly a historic moment, the first launch of 2 rockets, and we want to celebrate this historic moment together with everyone watching the live cast. And so everyone watching this live stream, please share your thoughts on X using the hashtag GoHTVX1 and GoH3F7, and we'll be featuring some of your comments during the program. And of course, we are checking all your comments. And please send a lot of comments. Then first, about the H3 rocket, Mr. Ishikawa, please explain. Okay, actually here are 4 boosters you can see, and already you may know that the job of the rocket is for that on the top of the rocket here is the fairing and the cargo is placed and it will be carried to the space, and this time HTV-X is contained here. And below that is just a tank, just a fuel. Okay, so most of the parts of the rocket is just a fuel. Yes, that's right. And that's for the H3. For instance, the flexibility, high reliability, and low cost. And actually, we are targeting to low cost, therefore, so that everybody can go to the space. And actually, it was developed with everybody power and ability. And actually, it achieved its first successful launch with the second test vehicle in February 2024. What does flexibility mean? Well, actually, the H3 rocket is designed to flexibly select its configuration for optimal launches tailored to each mission. And it can carry a diverse range of satellites, probes, and spacecraft according to specific objectives. And how many different types are there? There are 3, and there are 3 types: 30 configuration, 22 configuration, and 24 configurations. And actually, either 1 or 2 or 3 or 4, actually, that is classified. And also, and also the size of the tip fairing can be selected depending on the size. And so far, 2S was used, but this time on the right, 2 for wide is attached for the first time. Therefore, boosters are used for. It seems very powerful. Anyway, the chat says that people said that it's cool with 4 boosters, and that's why it can be very powerful. Okay, here, and I'd like to have some explanation from Mr. Arita about number 7.
今回打ち上げる H3 ロケット7号機はどのようなロケットなんですか？
H3 ロケットはお客様によって応じて最適な打ち上げができるように3つの形態を準備していますけれども、その中でも今回の7号機は最もパワフルな24形態を準備しています。この24形態はメインエンジンが2つついているという点では今までの5号機までと同じなんですけれども、周りについてます固体ロケットブースター、こちらが今までは2機ついていましたけれども、これが倍の4機になるということで、今までで一番パワフルな24形態という形になっています。
今回特に注目するポイントってありますか？
新しいフェアリング HTV-X を格納しているこの先端の部分なんですけれど、ここを今までと違ってちょっと太くて、しかもですね大きなドアが開けられるようになっています。これは HTV-X はいろいろなものを宇宙ステーションに届けるために打ち上げの直前までその荷物を搭載できるようになっているんですね。でそのためにこの衛星フェアリングの外側に大きなドアを設けて、打ち上げの直前までそれを開けて HTV-X の中に入ることができるように、そんな工夫をしています。
その他にも今回注目ポイントってありますか？
この7号機では2つの大きな技術実証を行いたいと思っています。その一つが自律飛行安全システムの飛行実証です。自律飛行安全というのは従来は地上からのコマンドでエンジンを止めたり機体を破壊したりっていうことをやっていたんですけれども、この自律飛行安全では機体に搭載したシステムでロケットが自分自身の状態や飛んでいる場所を判断して、これはまずいという時には自分でエンジンを止めたり破壊したり、こういった動作ができるようにするものです。それから2つ目が TDRS 対応開発というものです。これは従来はロケットから直接地上局に電波でデータを送っていましたけれども、これを静止衛星静止軌道上にある TDRS、 これを経由して地上に下ろしてくるというシステムです。これらによって 飛行経路を作る自由度、いろんな飛び方ができるようにすることができて、ロケットの能力を最大限引き出すことができるというものです。
最後に打ち上げに向けた意気込みと、そして視聴者の皆さんにメッセージをお願いします。
今回の7号機の打ち上げというのは、国際的にも注目されている HTV-X の打ち上げということ、それから H3 としても新しいチャレンジ、これがいくつかあります。ということで、これまで以上に気を引き締めて確実に打ち上げを成功させるように頑張っていきたいと思っています。ライブ中継をご覧の皆様にもぜひ応援していただけると嬉しく思います。よろしくお願いします。
This is H3 launch vehicle, flight number 7 to be launched soon. Mr. Ishikawa, how do you see Mr. Arita's interview? As you can feel from the film, he's a very gentle person, and Mr. Arita has been involved with H3 project since its inception, serving as sub-manager for test flights 1 and 2, and then leading the team as project manager starting with flight number 3. Arita-san is a very humble person and a calm person, emphasize the team building and team effort. So we always rely on him for his instructions and directions. We just follow what he said. As we see in the film, he seems to be a very calm person. So the team atmosphere is very great, isn't it? Yes. In the film, Mr. Arita also mentioned the features of flight number 7, and it has many different missions. Right. So let me explain the key points of flight number 7. The first of all is the new development for the HTV-X launch mission, and that is the fairing. And HTV-X is very large, and therefore the standard H3 fairing has a diameter of 5.2 meters, while this wide fairing is slightly larger at 5.4 meters in diameter. And then you see a large door in the photo. And this is to accommodate the late access procedure, where cargo such as fresh food and then other supplies can be loaded into HTV-X up until immediately before launch. The door measures 1.6 by 1.5 meters, has been installed. The maximum access door on the previous standard fairing was a 0.6 meter diameter, making this new door approximately 8.5 times larger in the area. This allows cargo to load it into the pressurized section beneath the HTV-X up until immediately before the launch. And then also, if you can see the left bottom, the separation mechanism has changed from the conventional clamshell design to open like this to a method where since the manufacturer has changed, the fairing is first lifted upward during acceleration and then open in the parallel direction. Yeah, I think that the rocket, I think that with it's open like that. Yes, it goes up and then open in a second stages. And then also inside the fairing, the satellite separation unit known as payload attach fitting or PAF was also newly designed specifically for HTV-X, ensuring sufficient height and an access port for late access. And then additionally, a clamp band system was implemented to minimize separation impact, resulting in a satellite-friendly design. So this is all newly developed for HTV-X. So how do you think that? So it is perfect. Our requests, we made a lot of requests, but they were carefully considered, resulting in a spacecraft we can rely on for HTV-X with confidence. Thank you very much. And compared to Konotori period, cargo handling operation also has significantly improved. So Thank you. So this is truly compatible with HTV-X. Thank you. And then also he mentioned about other demonstration projects. As Mr. Arita mentioned earlier, we will conduct two technological demonstrations. The first one is the autonomous flight safety system. Perhaps you may remember the term command distract from the first vehicle. This refers to the mechanism that holds flight to prevent accidents when rocket malfunctions occur. As you see in this chart, up until now, the JAXA rockets have ensured safety by constantly monitoring the rocket flight from the ground, and in the event of abnormality, sending signals from the ground command station to hold the flight. But this time, we will test the system where the rocket itself determines safety. So we will conduct experiments to acquire the data in the red area. So as you see, in addition to the green areas, so this time the flight is also possible into the red area. As you see the black the trajectory, which is not efficient because it has to achieve high altitude. But for example, in the case of HTV-X, the launch, the performance has improved by 1.5 times. So you are looking into the effect of the further possibility. The second point is the development of the H3 rocket for TDRS compatibility. Ms. Isogai, are you familiar with MMX? I think this is something about the mass. Yes, right. Currently, many people started to understand what MMX is about. It is a Mars Moon exploration mission. And for sample return for the first attempt in the world. So in future exploration missions like MMX, rockets should often fly far from ground communication stations, making communication from the Earth difficult. So as you see, so there are plans to use NASA's TDRS, tracking and data relay satellites, communication services. And this system uses relay satellites in space to communicate with rockets, even locations beyond the reach of ground stations. So after the separations over the Pacific Ocean, we will conduct the experiment for communication with NASA satellites. So you are further looking into the effect into the future with new possibilities. Thank you. So could you also explain the HTV-X, Mr. Nagahama? In front of me, you see this is a model of HTV-X. It looks very cool. The length is around 8 meters, diameter is 4.4 meters. So the length is about the same length as a bus, and height is also. The width is equal to the two buses which are placed side by side. The weight, the flight number 1 is about 15 tons, which is equivalent to about 10 passenger cars. As Mr. Ishikawa said, this is the launched in a powerful configuration. So it is as big as a bus and as heavy as 10 passengers cars. So I can easily imagine how large and how heavy it is. And then where the cargo is stored, there are two sections. And then here, it is placed in the rocket vertically, and this cylindrical area is called the pressure module, which is filled with an air with 1 atmospheric pressure, and it holds food and then other essential supplies to the ISS. And then upper side, or the opposite side, is the exposed cargo station, which houses various experimental equipment utilizing the space environment. So the shape looks very cool, and we received similar message on the chat. So it is kind of an open weather. This module represents the spacecraft in flight configuration, and then the solar panels are deployed. But in order to load it onto the rocket, the panels are folded. And then upper half is octagonal, and the lower half is cylindrical. So the shapes are different above and then bottom. And then after launch, in the space, the solar array panels open after the separation from the rocket. And then it flies in this attitude, and then the exposure cargo facing ahead. So that is the basic attitude of the flying. And they operated from the HTV-X mission control in Tsukuba. It approaches the ISS and they hold relatively stationary to the ISS at the distance of about 10 meters below the ISS. And the astronaut above the ISS targets this at the center with the robot arm to capture the gripping the mechanism located in this center. So in a huge space, it is stationary about 10 meters below the ISS to be captured. After capture, it will be docked to the ISS by the robotic arm in the opposite orientation. And then at the tip, the cylindrical section has a hatch in the silver-colored hatch, which is a door. And then the air is filled inside, and then astronaut will open the hatch to enter to receive the supplies. Thank you for the explanation. So now the new HTV-X space station reply vehicle, which will carry the future of the world. Please watch the film.
皆さんこんにちは。まさに宇宙への新しい扉が開かれる瞬間です。ここ筑波宇宙センターから日本の次世代宇宙輸送機 HTV-X1 号機の物語をお届けします。皆さんも一緒に歴史的瞬間を目撃しましょう。
ここまで日本の宇宙輸送を支えてきたコウノトリ。その後継機として HTV-X がついにミッションの途につきます。そんな HTV-X はコウノトリと比べどう変わったのでしょうか。
HTV と HTV-X ってどんな風に違うんですか？
輸送量を増強しました。 HTV は4トンの物資を ISS に運ぶことができるんだけども HTV-X は 1.5 倍の約6トンを積むことができます。あと例えば冷蔵庫のようなそういう冷やして ISS に届ける電気を必要なカーゴ物資も輸送できるようになりました。なので太陽電池パドルを展開型のこういうようなパネル式にして電力を 1.5 倍の派生電力を派生できるようにした。それによって電気が必要な物資に電力を供給するようなことも可能です。また宇宙で新しい技術を実験するための電力もこの大電力の太陽電池バトルで電力を供給することができます。これがHTV と違う向上した能力の代表的なところですかね。
こうした改良点に加えて HTV-X では荷物の最終搭載が24時間前まで可能になりました。これにより最適なタイミングで HTV-X へ搭載することができます。進化した HTV-X にどんな未来が期待されるのでしょうか。
HTV-X では輸送能力の大幅な増強に加えて運用の効率化によって運用のコストというのを下げていきます。それによって費用対効果が非常に高い宇宙船になります。まもなくポスト ISS と呼んでいる民間事業者等による地球低軌道の商業利用が本格化していきます。商業宇宙ステーションができるとそこに対するやはり物資補給というのが必要になってきます。HTV-X で獲得するシステムは将来の地球低軌道における活動において大きな貢献が期待されています。
では HTV-X は宇宙にどんなものを運ぶのでしょうか。 HTV-X は暴露カーゴと余圧カーゴという2つの搭載エリアにさまざまな荷物が積み込まれます。上部の暴露カーゴには実験機器に電力や通信を供給する ICEEP と呼ばれるアダプターが、下部の余圧カーゴには希望日本実験棟で使用される科学実験装置やサンプル、宇宙飛行士の生活用品などが搭載されます。今回初めて宇宙で二酸化炭素除去技術の実証を目指す DRCS が搭載されました。さらに日本のフレッシュな生鮮食品も HTV-X によって宇宙飛行士に届けられます。この他に宇宙空間での精密機器の性能を検証し、自動化・自律化技術の確立を目指すタスク PM、アジア太平洋の青少年が考えた実験に宇宙飛行士が希望日本実験棟で挑戦するアジアントライ 0G2025、 希望日本実験棟の船外から超小型衛星を放出する JSOT、 そして民間企業による希望利用機材も搭載し、宇宙利用の新たな可能性を開きます。ISS に届ける荷物の他に ISS 離脱後技術実証を行うための装置も搭載。多彩な挑戦が HTV-X に託されています。このように HTV-X は数多くのミッションと未来を背負い宇宙へと旅立ちます。
どうしているかというのをちゃんと先に把握するというのが大事です。そのための要素技術が HTV-X を使って行うこの姿勢把握、姿勢運動決定実験で分かるはずだと信じてます。
今回のミッションの狙いは何ですか？
最終的に実現したいのが宇宙太陽光発電システムというもので、大きさとしてはもう2キロ四方ぐらいの非常に大きなもので、それに向けた第一歩の実証が今回のディライトでの実証になります。
具体的に今回はどのような実証を行われるんですか？
新しく考え出したパネルを展開したりとか結合したりする機構があるんですけど、メカニズムがあるんですけど、それが宇宙でちゃんと動くかっていうのを検証したい、実証したいというのが一つと、あともう一つは非常に軽いアンテナをそこに搭載しようとしているので、そのアンテナ、これなんですけど、これがちゃんと宇宙で動くかっていうのを見るというのが、その2つが ディライトでやりたいことになります。大きなアンテナとか大きな構造物が作れると、今までその宇宙ミッションとしてやってるその地球観測とか通信とか災害監視とか、それらのそのグレードアップ版っていうのがどんどん実現できていくので、我々の暮らしにとって、今でも宇宙開発って役に立っている部分はあるんですけど、それをさらに上げていくっていうのができると思います。
超小型衛星放出ミッション HSAT。HTV-X から超小型衛星を放出します。 HTV-X の特徴である自在な飛行能力を生かし、 ISS よりも高い高度から衛星を放出します。これにより超小型衛星の運用期間の延長や実用的な利用ミッションへの応用を可能にするなど、新たな需要を引き出します。
では最後に打ち上げに向けた意気込みと視聴者の皆さんへメッセージをお願いします。
はい、10年かけて開発をしてきて、準備万端、満を持して打ち上げに臨みます。皆さんの期待に応えてミッションを成功させて、皆さんと一緒に喜びを分かち合いたいと思ってますので、皆さんどうぞご期待をしていただきたいと思います。
この後間もなく打ち上げです。歴史的瞬間を共に目撃しましょう。ナレーターは木村昴でした。
いや、補給機としての役割の部分だけでかなり進化しているのに加えて、
Only the risk-free vehicles actually already it's made a great progress, but at the same time, technological verification will be done. Mr. Nagapama, that is something fantastic.
So as Mr. Ito mentioned at the beginning, it took us 10 years for the development. I involved from the beginning of the development, and we faced with a lot of challenges and difficulties. So I'm a bit emotional right now. That message has been spread to the audience. Mr. Ishikawa, how do you think about? This is the first vehicle, yet it has many missions in addition to cargo transport mission. So this will be heading to the ISS. So could you tell me about the ISS? Yes. So this is ISS. The orbital altitude is 400 kilometers above the Earth, circling the Earth every 19 minutes. And it is jointly operated by 15 countries. And it is a massive space station, roughly the size of a soccer field. So it's very big and operated by 15 countries. And what the role Japan is playing? In the ISS plan, the Japan developed Kibo Japanese experiment module, where scientific experiments are conducted utilizing the space environment. And ISS, now the Mr. Yui is currently aboard the ISS. Yes, right. And then Mr. Yui will be capturing. So therefore, from Tanegashima, the HTV-X spacecraft will be launched to the ISS and captured by the Japanese astronaut Mr. Yui. So HTV is just for cargo transport, but it's a two-way player with technological demonstrations. Yes, right. It is two-way player. So it transports the cargo to the ISS, and then after that, as you can see, various missions will be conducted for about 1 year. This is a new attempt, so we are determined to complete these missions. Thank you very much.
It's 8:44, and actually, there is 15 minutes until launch. How is the rocket looking? But actually, now I heard from us about Nate, this through using the backside channel, and the weather is so perfect. Therefore, probably separation of this can be seen. And okay, let's check the LCC. Okay, this is LCC. People are now checking watching the monitors, and actually they are doing the final confirmation before the countdown, and also it's also connected to this one RCC. Yes, and actually, after the launching, they will monitor and control, and Mr. Arita is
You are looking
sitting
live at
just
the
over there.
Yoshinobu Launch
You can
Complex
see,
at the
and everybody is very much ready. Then next, okay, let's introduce today's flight sequence. And here is the flight sequence for the H3 rocket number 7. And maximum dynamic pressure occurs approximately 40 seconds after liftoff.
Tanegashima, where the countdown is proceeding on track with no issues reported, as we are at T-minus 14 minutes and 30 seconds and counting as you look at the H3 rocket on the pad at the Oceanside launch pad in southern Japan. Good evening from Mission Control in Houston and the International Space Station Flight Control Room at the Johnson Space Center. This new cargo vehicle, the heir to the H2 transfer vehicle that flew 9 successful resupply missions to the station between 2009 and 2020, is ready to pick up the baton and deliver almost 4.5 tons of food and supplies to the complex and the Expedition 73 crew on board the orbital outpost. This was the scene at about 4:30 a.m. Central Time this morning in the Saturday evening hours in Japan as the H3 rocket was transported to the launch pad. It took about 30 minutes for this trip to take place from the integration building in Tanegashima to the launch pad where the H3 rocket currently sits awaiting liftoff. Once it arrived at the pad, the JAXA engineers hooked up electrical, fuel, and telemetry lines and began final pre-launch preparations. And you see the H3 rocket on the pad right now as the countdown is proceeding with no issues reported. This launch has finally reached the terminal phase of the countdown after several days of weather delays at the launch site. But today, Sunday morning in Japan, the weather is mostly clear, some partly cloudy skies, and balmy temperatures as we await the launch of this new cargo vehicle, the HTV-X1. The launch time is scheduled at 7 p.m. and 15 seconds Central Time, 8:15 and 8 p.m. and 15 seconds Eastern Time, which will be 9 a.m. and 15 seconds Japan time on Sunday morning. Once the HTV-X1 arrives on orbit, JAXA engineers at the main control center in Tsukuba, Japan, will put the vehicle through a series of systems demonstrations.
Okay, everybody who are watching the
私はですね、今こちら国際宇宙ステーションにいます。で、宇宙ステーションの中の希望日本実験棟の中にいるんですけれども、ね、ちょっと宇宙にいることが分かるようにいろんなことを見せてみたいと思うんですけど、こんな感じでね、無重力で自由に上下左右関係なく動ける楽しい環境にいるわけなんですけれども、いよいよですね、H3 ロケット7号機、そして HTV-X1、こちらの打ち上げの瞬間が迫ってきていますね。私も本当にドキドキしてますし楽しみなんですけれども、補給機っていうのはですね、私たちがISS で仕事をするために本当に大切なものをね、食料はもちろんですけれども実験機器なんかも運んできてくれますし、いろんなね生命維持装置の、スペア部品であるとか、もう本当にたくさんのものを、運んできてくれます。私たちの、生命線みたいな、そんな重要なミッションなんですけれども、その重要なミッションの、一つをですね、日本が担っているっていうところが非常に誇らしいですね。最後に物を積むのもですね、前回に比べると打ち上げギリギリまで、荷物を積むことができるので、新鮮なものも、届くと思います。ちょっと野菜は苦手ですけれども、フルーツなんかはね、非常に楽しみですし、他のクルーはね野菜や、多分、果物、新鮮物は何でもウェルカムですので、そういうものが入ってるといいななんて思いながら、待ちたいというふうに思っています。私はこの挑戦をですね、宇宙から見守りたいと思います。 皆さんは、地上でこのライブ配信で、その様子を、ご覧ください。歴史的瞬間ですからね、お見逃しのないようによろしくお願いいたします。
さあということでゆいさんからの
tuning mid-course correction burns to reach a point directly below the station in the neighborhood of the ISS on Wednesday morning, where it will inchworm its way up that R bar, the radial vector, the imaginary line drawn between the station and the Earth, to reach a point about 30 feet away from the station. That's where Yui and Cardman will extend the Canadarm2 robotic arm and reach out and grapple HTV-X for its installation on the Earth-facing port of the Harmony module. The HTV-X is comprised of two major components, a pressurized module. This is based on the legacy HTV design for a pressurized logistics carrier. It contains most of the control and power components for the vehicle itself. The service module contains 3 integrated flight computer strings, 3 different strings of propulsion capability, guidance and navigation and control sensors, communications equipment, and the power configuration for the free flight, those solar arrays and batteries on the vehicle itself. Once it is mated to the International Space Station and bolted into place on Wednesday morning, the HTV-X will derive station power for the duration of its stay on board the International Outpost. You can see the countdown clock at the top of our feed, courtesy of JAXA, the Japan Aerospace Exploration Agency, as we are now inside 8.5 minutes until liftoff. There will be final systems checks by the engineers at the Launch Control Center in Tanegashima. Prior to the ignition of the main engine and the solid rocket boosters, the H3 rocket will take off rather quickly, clearing the tower and arcing out to the northeast from the launch site. Before HTV-X arrives at the International Space Station on Wednesday morning, there will be a series of systems demonstrations, as we mentioned earlier, first during what is called the Far Field Rendezvous areas. Those will test out the performance of the absolute global positioning system on board the vehicle, as well as the performance of the vehicle's attitude, its orientation relative to Earth, its free drift capability, basically disabling all of the thrusters on board to see how stable the vehicle is without thruster capability. It will also test out an abort capability should that become necessary because of a systems issue. Once the HTV-X arrives in the neighborhood of the station, they'll perform 6 demonstrations during what is called the near-field rendezvous time frame. That will be assessed by engineering and operations teams on console before the International Space Station Mission Management Team meets on Tuesday to review the performance of those demonstration tests and provide a final go for HTV-X to arrive at the station on Wednesday morning. Some of the near-field rendezvous demonstrations will include a relative GPS performance test, a link of the proximity operations equipment and the ability of the crew on board the station to send commands to the vehicle, the testing of various sensors, the performance of the capability of the HTV to hold itself, basically put on the brakes and hold steady in the near vicinity of the station, and a retreat and abort performance capability as it climbs up that radial vector towards its grapple point. It will then back away and then proceed on, assuming all of its systems are functioning normally. We're at T-minus 6 minutes and counting towards liftoff. Again, no issues being reported in Tanegashima by the launch control team comprised of JAXA engineers and Mitsubishi Heavy Industries, which built the H3 rocket.
It's 6 minutes to launch. The current weather at the launch site is sunny. Temperature is 24.6 degrees Celsius. Wind is 4.6 meters per second from the north-northwest. Weather is green for launch.
本日の打ち上げ予定時刻は日本時間の午前9時00分15秒です。
320
Liftoff is currently scheduled for 9 o'clock a.m. and 15 seconds Japan Standard Time.
310 309 308 307 306 305 304 303 302 301 300
打ち上げ5分前です。
It's 5 minutes for launch.
95 94 93
衛星系準備完了。
The satellite system is go.
88 87 86 85 84 83 82 81 280 79 78 77
We've reached the T-minus 4-minute 30-second mark in the countdown. Again, the launch engineers in Tanegashima working no issues. The range is clear and everything looks to be in good shape for an on-time liftoff.
62 61 260 59 58 57 56 55 54
Once again, reviewing quickly the milestones between launch and the rest of the ascent time frame. The solid rocket boosters will separate about 2 minutes after launch, followed about a minute later by the jettisoning of the payload fairing at the top of the H3 rocket, within which the HTV-X1 cargo craft is encapsulated. First stage separation is scheduled 5 minutes after launch. It will separate from the rest of the stack. The second stage separation comes 9 minutes later at about 7:14 p.m. Central Time, followed 28 minutes later by solar array deploy.
Pressurization process of second stage liquid hydrogen has been initiated.
97 96 95 94 93 92 93 91 190
There's a view of 3 of the 4 solid rocket boosters at the base of the H3 rocket, which again rolled out to the launch pad about 14 hours ago.
3 minutes for launch.
74 74 73 72
一段液体酸素地上油圧開始。
Pressurization process of first stage liquid oxygen has been initiated.
機体の電源が外部から内部に切り替えられました。
The power system of the launch vehicle has been switched to internal systems.
55 54 53 52 51 150 49
The first stage of the rocket is being purged right now.
44 43 42 41 140 39 38
The rocket now in stable replenish with its load of liquid oxygen and liquid hydrogen, approaching the T-minus 2-minute mark.
29 28 27 26 25 24 23 22 21 120 19 18 17 16 15 14 13 12 11 110 109 108 107 106 105 104 103
Assuming everything goes as planned, the HTV-X, this brand new cargo ship for JAXA, will arrive at the International Space Station on Wednesday morning, with capture scheduled at 10:50 a.m. Central Time, 11:50 a.m. Eastern
Liquid
Time.
oxygen has been initiated.
85 84 83 82 81
T-minus 1 minute 15 seconds.
78 77 76 75 74 73 72 71 70 69 68 67 66 65 64 63 62 61 60
打ち上げ1分前です。
We have less than 1 minute to launch.
54 53 52 51 50 49 48 47
All systems reported to be go, as we are now at T-minus 40 seconds and counting.
40 39 38 37 36
ウォーターカーテン散水開始。
The water curtain system is activated for launch pad.
フレームデフレクター冷却開始。
The cooling water system for the flame deflector is activated.
22、21、20、19、18、17、16、15。フライトモードオン。
The flight mode is on.
12、加工品トーチ点火。
The torches are ignited.
全システム発射準備完了。
All systems are go.
メインエンジンスタート。
The main engine ignition.
SRB3 点火、リフトオフ。
Solid boosters are ignited. Lift off.
HTV-X1 を搭載した H3 ロケット7号機は2025年10月26日午前9時00分15秒に種子島宇宙センターから打ち上げられました。
We have a successful liftoff of H3 launch vehicle flight
rocket
number.
arcing out to the northeast from the launch site. 30 seconds into the flight, all systems reported go. Good trajectory reported by the launch engineers at Tanegashima. The liftoff time confirmed at 7 p.m. and 15 seconds Central Time, 9 a.m. and 15 seconds Japan time on Sunday morning. One minute, 10 seconds into the flight. Good trajectory, good vehicle performance, good stability on the vehicle. All of the H3 systems, first stage performance looking good. We're expecting solid rocket booster jettison in about 20 seconds or so. And SRB separation is confirmed. Next up, the jettisoning of the payload fairing. This is a plot board at the Launch Control Center in Tanegashima showing the trajectory of the H3 rocket. 2 minutes, 35 seconds into the flight. Three minutes into the flight, everything looking good. The reports from the Launch Control Center indicating good first stage performance, good trajectory on the rocket. And we now have confirmation of payload fairing separation. Next up will be first stage separation about a minute and 10 seconds from now. Once again, you're looking at a plot board at the Launch Control Center in Tanegashima, Japan, in southern Japan. We're at the 4-minute 20-second mark into the flight of the H3 rocket to deliver the HTV-X1 cargo craft into its preliminary orbit. We're about 10 seconds or so away from first stage engine cutoff and separation, as you can see on the plot board. And we have confirmation of first stage separation. The second stage engine has ignited, up and running, looking good. Good trajectory, good stability on the H3 rocket, now running on the singular power of its second stage engine. Coming up on the 6-minute mark into the flight. This second stage engine will burn for about 9 minutes. Once again, the launch of the H3 rocket carrying the HTV-X1 cargo craft on its maiden flight occurred on time at 7 p.m. and 15 seconds Central Time, 9 a.m. and 15 seconds Japan time on Sunday morning from the Tanegashima Space Center. We're about 6.5 minutes away from second stage shutdown and separation. The HTV-X1 cargo craft will reach a preliminary orbit about 186 statute miles above the Earth, and will begin almost immediately with a series of demonstrations of its global positioning system hardware. A series of demonstrations called far field demonstrations will take place throughout the course of the overnight hours into Sunday morning, U.S. time. The first critical rendezvous maneuvers are scheduled for late afternoon U.S. time on Sunday afternoon, leading to a rendezvous with the International Space Station on Wednesday morning. 8.5 minutes into the flight, everything continues to look good. A little under 5 minutes to go before second stage shutdown and separation, spacecraft separation to follow seconds after that. Good reports coming in from the Launch Control Center in Tanegashima. good second stage performance, good vehicle stability. The HTV-X1 is carrying about 4.5 tons of food, supplies, and science experiments for the Expedition 73 crew aboard the International Space Station. The station crew was asleep at the time of launch. They'll be informed of the results of this liftoff once they are awakened several hours from now. The International Space Station and its 7 crew members are flying from southwest to northeast in an orbit inclined 51.6 degrees to either side of the equator, approaching the west coast of Africa. Less than 3 minutes to go before the scheduled cutoff of the second stage engine and the separation of the HTV-X1. From the time of spacecraft separation until solar array deploy, it will be about 28 minutes or so. We will remain on the air to report the solar array deploy. Just to repeat, a number of systems demonstrations called far field demonstrations and near field demonstrations will be conducted with the HTV-X1 cargo craft. Basically, the engineers in Tsukuba, Japan, at the HTV control room will take over control of this flight from the Launch Control Center engineers in Tanegashima. Handover to the engineers in Tsukuba will take place at spacecraft separation, and they'll be monitoring the HTV-X's systems, as will the visiting vehicle officer here in Mission Control in Houston, ensuring that all of the HTV-X1 demonstration tests are conducted as planned before the HTV-X arrives in the neighborhood of the space station on Wednesday morning. We're 13 minutes into the flight. We're about a minute away or so from second stage shutdown, and spacecraft separation. Will stand by for that confirmation. Approaching the 14-minute mark into the mission, standing by for second stage shutdown. And we have confirmation of second stage shutdown and spacecraft separation, and you can see the jubilation in the Launch Control Center room in Tanegashima. It was a flawless liftoff on time. All of the ascent milestones were conducted as planned to deliver the HTV-X1 into its preliminary orbit.